Hello everyone, welcome to this video. So today we're going to learn about binomial theorem and we're going to learn a bit more than what is taught in school. So this would be also applicable for JEE, main and advanced, and also for Olympiads like RMO and INMO. And in addition to that, we will do some problems which might also appear in ISI and CMI. So all in all, we're going to start from scratch and then go up the ladder and to try and understand how to do difficult sums related to binomial theorem and how to apply calculus. So let's start off with the basics. We should first know what a factorial means. So n factorial is defined as n multiplied by n minus 1 multiplied by n minus 2 all the way up to 1. And this is valid for n belongs to natural numbers. And 0 factorial is defined as 1. So it is 1 by definition. And from like 1 and up, like all the integers are from 1 onwards, we can have this definition. So for example, 1 factorial equals 1, 2 factorial equals 2, 3 factorial is 6, 4 factorial is 24, 5 factorial is 120, and so on. An important property about factorials can be stated like this. N factorial is then can be written as n into, and if you consider everything from n minus 1 to 1 as well, that is itself n minus 1 factorial. So we can write n factorial is basically equal to n times n minus 1 factorial. So this is an important observation, although it is very simple in nature. Once you know the definition that, yeah, n factorial is basically the product of all the integers from 1 to n consecutively, then you can deduce this immediately. But this is something we need to keep in mind because this is used often while solving problems. Once we have this, we are now going to define what is called a binomial coefficient. So a binomial coefficient. So a binomial coefficient is written either in the form NCR or in the form which I prefer n choose R. So this is called n choose R and this can be represented in these two symbols. And I'm going to use this one for the rest of the video. What does it mean? This means the number of ways to choose R items from a box of n items. So we are given, let's say, n items in a box. There is a box and there are like n items, A1, A2, all the way like more items and then A, like total of n items. And we are asked how many ways we can choose a collection of R items where R is less than equals to n from this box. The answer becomes n choose R. And the definition of n choose R, the mathematical definition then is given by n factorial divided by r factorial whole into n minus r factorial. This is the mathematical definition of n choose R, and this is always an integer. This is always an integer since the number of ways cannot be fraction. So that also equipped with the fact that if you observe carefully, this is also equal to n choose n minus r. So n choose r is basically equal to n choose n minus r because if you write out from the definition, the value of this quantity using factorials as we have done here, you can see that n minus r factorial comes first and then n minus of n minus r basically becomes r. So they are the same thing. Okay, so let's move forward. Some examples would be 2c1 is equals to 2 factorial by 1 factorial into 2 minus 1 factorial, which is simply 2 factorial by 1 factorial into 1 factorial. This is equals to 2 factorial, which is 2. Let's do another one, 5c2. 5c2 should be 5 factorial divided by 2 factorial into 3 factorial. 5 factorial can be written as 5 into 4 into 3 factorial, right? Divided by 2 factorial into 3 factorial. We can cut off the 3 factorials. Since 2 factorial is 2, we can cut this with this one and we get 10. Now, a better way to calculate these combinations is simply this. If you have n choose R, you can simply write n into n minus 1. And you do this for R items. So basically you do this up to n minus of R minus 1, which is n minus R plus 1 divided by R factorial. This is a better way to find and a faster way to find it. So in that method, if we were to do 5c2, we could simply write 5 multiplied by 5 minus 1 divided by 2 factorial, which is nothing but 5 into 4 by 2, which is 10. As you can see, this is faster. At least for our brains to comprehend, this method is faster. But yeah, all of them will give you the same result. Okay. So uh, we are done with binomial coefficients, and we now know how to deal with factorials from this one. We are now ready to state the binomial theorem. So the binomial theorem states that for numbers a and b, and I say numbers, so they can be complex, real, anything, and a positive integral index n, which is also not true because this is also true for other indexes. Like if the exponent is not integer, even then we can define it. But for the sake of JEE and stuff, we are not going to do it right now. So that is an advanced topic. So this expansion is basically given by this summation. Summation from r equals to 0 to n choose r, a to the power n minus r into b to the power r. So this expansion is this is the basically the expansion of a plus b whole to the power n. If you write it down term by term, it simply looks like this: nc0 a to the power n plus n choose 1. So the coefficients increase like this, the base of the coefficients, n choose 0, n choose 1, n choose 2, and so on. And once you get forward, the sum of the exponents of a and b should always match it. So here, the exponent of a to the power n decreases by 1, so it becomes a to the power n minus 1. And similarly, to match the sum becoming n, we have b to the power 1. The next term then should be n choose 2, a to the power n minus 2, b squared, and all the way up to n choose n, a to the power 0, and b to the power. The motivation behind this is a plus b whole to the power n. This can basically be written as a plus b multiplied by a plus b, and there are n such copies, right? And when we are multiplying all these copies, we will get terms of the kind a to the power m, b to the power n, where m and n will where the sum of m and n will basically never exceed n. So let's not call it n, actually, it's coinciding. So m and p, and where m plus p is always less than equals to n, right? So we'll get terms of all kinds. Like let's say if n is 5, then we can get terms of the kind a square, b square, or maybe ab to the power 4. Actually, this should be equals to n. AB to the power 4, a to the power 5, basically a to the power 4b, a to the power 5, and all those kinds. And for each of those kinds, the number of ways to do select those terms is the basically the coefficient of the term, and that is given by these combinations. So out of all of this, how many terms do we get where there are like the exponent is n? So obviously one term, because when you multiply all the a's, you get that. So that is why n choose 0, and then n choose 1, and so on. So that is how the binomial theorem is basically proved. Okay, so with this in hand, we are going to deduce some formal corollaries from this. So this is another useful expansion. If you set a as 1 and b as x, you get this expansion, which looks something like this: r equals to 0 to n choose r. Since a is 1, we simply get b to the power r. If you expand this, this looks something like this. The first term is 1, and the next term is n choose 1 b, n choose 2 b squared, and so on. And the last term is b to the power n. This is the expansion of, let's call it bx. Yeah, this is the expansion of 1 plus b to the power n, 1 plus b whole to the power n. So why am I doing this? Because this expression on the right hand side will basically occur a lot of times in problems while doing problems from this competitive examinations, and you immediately need to recognize that okay, this is the expansion of 1 plus b whole to the power n, or if it is x, 1 plus x whole to the power n, and then proceed on to do the sum. Okay, so we are kind of done with the basics. So I'll just revise it once again. The definition of factorial: 0 factorial is 1. Then we define the binomial coefficient and its factorial notation. We then went on to do some, but we did some binomial coefficients by hand using two methods. One using the factorial notation, another one basically the same but still reduced form, something which would basically help you to do it faster. So n choose r is basically product of n, and you go back r times. So product of r consecutive integers starting from n backwards divided by r factorial. Okay, and then we introduce the binomial theorem, which is this. Now with this in hand, we can try and do some sums. So First of all, what would be the expansion of 1 plus 3x whole to the power 10? So let's start with sums of this kind. So from the binomial theorem, we know that the answer should be of the form r equals to 0 to n choose r, a to the power n minus r, b to the power r. Now, what is a and b here? If you compare it with our equation a plus b whole to the power n, you can see that a is 1, b is 3x, and n is 10. Plug in those values and you should get this summation r equals to 0 to 10. 10 choose r. Since a is 1, a to the power n minus r is always 1, and b to the power r is basically 3x whole to the power r. This is the expansion of 1 plus 3x whole to the power 10. So plug in you have to, whenever you're given an expansion and you have to expand and show it, you can basically compare it with the expansion of a plus b whole to the power n, and then you can plug in the values. Now, we can use this to our advantage to find a lot of finite sums which are given. Let's say, for example, 1 plus x whole to the power n, as we have discussed earlier, this should be equal to something like this. 1 plus n choose 1x plus n choose 2x squared, and this goes up to n choose n x to the power n. The first term is also n choose 0 basically, but I've written it as 1. Now, what happens if you put x equals to 1 here? When you do that, what you get is 2 to the power n, because this term becomes 2. And the right hand side simply becomes the sum of the binomial coefficients, since all of the x's turn to 1. N choose 0 plus n choose 2 plus n choose 3. Actually, there is n choose 1 as well. N choose 1 and all the way up to n choose n. So sum of all the binomial coefficients from for NCR, where r is from 0 to n, is equal to 2 to the power n. We can write this formally as follows. Summation r equals to 0 to n choose r, or NCR, is equal to 2 to the power n. It's important to note that the sum of the even counterparts like NC0 plus NC2 and whatever even number there is at last, it could be NCN or NCN minus 1, whichever it is. So let's consider n as an even number. So NCN is the last. This is equals to 2 to the power n minus 1. And the odd ones, NC3 and all the way up to NCN minus 1, this is also equal to 2 to the power n minus 1. You add them up, you get this, and that the sum on the right hand side also becomes 2 to the power n. This is important to note, and you can prove it yourself. You can try and prove it yourself, but just play with the equation of 1 plus x whole to the power n equals to that expansion and try and plug in different values of x. You should get the answer. Okay, so that is one way. Okay, so there are a lot of sums that needs to be explored that can be done using this kind of properties. Let us discuss one more of those kind. Let's say we are given the sum r equals to 0 to n r square n choose r, and let's say divided by 2 to the power r. What is the value of this sum for any n? So r square divided by 2 to the power into n choose r. Now this looks like a very complicated sum, but let's try and evaluate it. I will write it separately and I will call it s. So r equals to 0 to n r square upon 2 to the power r whole into n choose r. So let this be the sum we're required to find. Now, you know this quantity, you know that r equals to 0 to n choose r becomes 2 to the power n, but we cannot do it anymore, because if you were to expand it, you would see that the terms basically are 0 plus r equal, when you put r equals to 1, this becomes half and choose 1. When you put r equals to 2, it becomes 2 square by 2 square. So basically n choose 2, and then r equals to 3 would be 9 upon 8, and choose 3, and so on. So this is not same as before, and you have to find it for any n. Any n belongs to natural numbers. Okay, so how can we do this? We can do this using the expansion that we had discussed earlier. So let's say that 1 plus x whole to the power n, where x is a variable, and this identity is simply equals to r equals to 0 2n, n choose r, x to the power r, correct? Now, since x is a variable and this is a finite and it's a polynomial, it's basically a polynomial because n choose r are just numbers, right? They're written in this form, but they're just numbers where n and r are constant. If you differentiate both sides with respect to x, what do you get? You get this n into 1 plus x whole to the power n minus 1 equals to, and since this is a summation, you can differentiate directly inside it because this is just a bunch of collection of different terms which are summed together, right? So n choose r remains as it is. We only differentiate this. We get r into x to the power r minus 1. So as you can see, we have obtained the first r which was not there before. Okay, differentiate it again and make it r square. But if we do it now, what we get? We basically get r minus 1 is a coefficient which we do not want. So multiply x to both sides like this. And what you get is this now, n into x whole into 1 plus x whole to the power n minus 1 equals to r equals to 0 to n ncr r into x to the power r. And now when you differentiate it again, so this side becomes x into this differentiation. So basically this becomes n minus 1 into x into 1 plus x whole to the power n minus 2 and then plus 1 plus x whole to the power n minus 1. And the right hand side becomes summation r equals to 0 to n choose r, and this again becomes r squared x to the power r minus 1. So we are going to copy this result to the next page, and let's see. The result was as follows: summation r equals to 0 to n ncr r squared x to the power r minus 1 was equal to, let's see, n whole into n minus 1. So n whole into n minus 1 x 1 plus x whole to the power n minus 2 plus 1 plus x whole to the power n minus 1. Okay, so this was the result. Now, if you multiply x to both sides, you get this r equals to 0 to n ncr r squared x to the power r, and we have multiplied x, so this becomes n into n minus 1 x square 1 plus x whole to the power n minus 2 plus n x 1 plus x whole to the power n minus 1. And now simply put x equals to half to get our desired sum. So therefore, S, which is equal to r equals to 0 to n ncr r square upon 2 to the power n. This is what we started with, right? If we put x equals to half, this is exactly what you get from here. So we'll also put x half in this equation, and we will get n into n minus 1 into 1 by 2 square. And inside we get 1 plus 1 by 2, which is 3 by 2. So 3 by 2 whole to the power n minus 2 plus n by 2 into 3 by 2 whole to the power n minus 1. Let's simplify it. So this becomes n into n minus 1 into 3 to the power n minus 2 divided by 2 to the power n plus n into 3 to the power n minus 1 divided by 2 to the power n. And the final answer is then we divide everything by 2 to the power n, and we can write this one as n into n minus 1 into 3 to the power n minus 2 plus n into 3 to the power n minus 1. This is our final answer for the given sum. So I hope you understood all the steps. If not, you can just review it by playing the video back. But this is how we can use calculus and binomial theorem to our advantage in order to find these difficult sums, which might look like almost impossible to solve at first. But you can use calculus extensively from here. Okay, so that would end the video here, and I would continue with example problems in the next video. So let me know how you liked it. Please let me know in the comment section, and also do subscribe to the channel. Thank you.